About your team.
Hi, we're Team 8593 from Bonneville Hills Middle School. Our team name is No Limits because there are no limits to what we can do. We named our robot Odyssey based on the movie Space Odyssey and the fact that it takes place in outer space where there are no limits. Our coaches are Mr. Polito, Mr. Benson, Mr. Cook, and our mentor Nathan Martin, who's an engineering student at Kettering University. We rank in ages from 5th to 8th grade. We started as an FLL team in 2012 and we picked up some new team members along the way. And this is our first year as an FTC team, and we're excited to be moving up.
So this is our board, and this is our team members and a picture of all of us. For building wiring, we started off with just a bunch of material, and it turned out to be a really cool robot and all of our ideas in between. For outreach, we went to 3 different places: Boston Rock Products, Oakland University, and a 5th grade classroom at our school to teach about FTC robotics. For programming, we have a couple pictures of people programming and some of our programming teammates. For sponsors, we have 4: Quality, General Motors, Custom Pops, and Consumer Center.
Okay, I'll be talking about robot strategy. And so our strategy was to score big. We didn't want to score little and just get 1 or 2 points in the little tubes per centimeter. So we made a plan to score on the 90 centimeter goal. So we came up with our lift here and our PVC tubes that would raise up and score on the 90, and it's very effective. And then our other strategy was, since it was easy to drag goals around, and that's one of the simpler things to do in this competition, we decided to figure out how to do that. So we have we call it the spear in the front, which drops down, grabs the tubes, and then drags them into the scoring zones. And then our autonomous strategy was originally to drive off the ramp and score in one of the tubes. He gets 60 points per ball. And then our mat program is to drive out, knock down the pole, and come back into the zone.
So I'll be talking about the building. So pretty much our entire team worked on the design and the chassis of our robot. So a couple main components are that our wheel works with the chain and sprocket here. So we have a conveyor belt to pick up the large balls, since the small balls are first a lot smaller, so they won't score as many points. And once it is fed through the conveyor belt, would be fed into the PVC pipe, which was specially made by one of our sponsors, Carlson Metal Products. And then once it is in here, we have a servo motor that keeps the balls in, and once we lift it up using a pulley system, we can also dump it out using this same servo motor. And we also have this steel block, which is used as a counterweight, because in our previous tournament, our robot fell off, so that helps a lot. Also, these plates that we use for our electronics protect our electronics in case of that flip, because if they were on top, they would have been damaged a lot. So right here, we have our spear, which we use to move around rolling goals by putting the spear inside of one of the holes on the base of the goal.
Can you turn it the other way?
Yeah.
The other side.
Oh, sorry.
Okay, I will be talking to you about wiring. So there are many main components in wiring, and without them, our robot would just be a bunch of pieces put together. Some of the main components are the NXT brick, the on and off switch, the battery, DC motors, DC controllers, servo motors, and servo controllers. And these are all connected through wiring. And our cement module, of course. And without wiring, none of these would work together and build the robot that we have today. Now, wiring is complex, but no more than any of the other things we are talking to you about today. Wiring is very precise, because if you screw up one wire out of 50, you have 49 wires to check. And boy, would that be a lot of work. So, actually, there's a funny story about our Samantha module that I would like to tell you. We couldn't find out, because the Samantha module connects the Wi-Fi to the NXT brick. We couldn't find out why it wasn't working. And so, since we work at 2 places, our immediate idea was that it could be either place. Turns out it wasn't either place's Wi-Fi connection. And then we, through process of elimination, we found out that it was actually the laptop we were using was like using up all the Wi-Fi for our robot. So we decided to switch laptops, and ever since it's been working fine.
Jake and I are going to be talking about programming. So we are a new FTC team, and we're all new to LabVIEW. So the NXTG software is a lot. It seems like a really large change to LabVIEw, but as we kept going, you figured out a lot more things that we can do, and how a robot can work, how we can make a robot work well.
And we were learning throughout the whole process of building the program and building the robot and constantly adapting to our ever-changing needs of the robot.
And so in the beginning, it's really hard to have somebody to have the building, the people who are working on actually building the robot. It's hard to have people working on the robot and also be programming it, because you need the robot to program it, but then you need the robot to build it. So we made a robot called ProgramBot, and it's in the engineering notebook. And it's just a little robot that we made that we could practice programming and work on LabVIEW skills, so we could be prepared for the actual robot once it was done.
We also had to do a lot of math in the LabVIEW program, because the original wheels were 3-inch and ours were 4-inch, so we had to recalculate the whole thing to get to the equation which we have now. And also because our motor has more torque to turn the big gear on the wheel, so we had to multiply that by 2 also to get to the encoder counts.
I'm here to talk to you about outreach. In our outreach, we have kind of a community. So then to cause the metal and his students had some very interesting robotics things that they made. Had like a magic 8-ball robot, and it would pick a card and it would say yes or no, and that was really cool. So we also tried programming ourselves, and we found out it wasn't easy. Just a simple task like picking up a block and then dropping it inside a box, it wasn't very easy at all. It actually took a while. Then Turquoise Metal Products, we're very thankful to have them. They're one of our biggest sponsors. They helped us make a lot of our custom parts, and without that, our robot wouldn't be able to work the way it does. So we're very thankful for them. When we went there, we had a small tour of the factory, and they had this big machine that pressed holes through these big sheets of metal, and it did it in like 8 minutes flat. And it was really cool. They were really loud though. As we found out, they also made robotic parts, like chassis, for a different company in Massachusetts. So that was pretty interesting to find out.
I will also be talking about outreach. So since our team started in 2012, we've had some major similarities. For example, each year we go to our team school and talk about our robot and FIRST Robotics. Each year, students have asked us, how can I join your team? When can I join your team? Or how may I make a team of my own? This year, we went to Lily's 5th grade classroom and talked about our robot, what to expect to the next level of FIRST Robotics, and we encouraged them to join FIRST Robotics. Our school now has 4 FTC teams, while the other 2 schools in our district only have 1 between the 2 of them. And I speak for my whole team when I say we are very proud to promote FIRST Robotics at our school. Thank you for your time.
Very good. Thank you. Anything else you want to tell us? About 30 seconds. Okay.
I have a question. You recognize this picture?
Yep.
Who can explain what this object is to me?
That is the object that they use to program like the magic 8-ball machine, like my friend Dia told you about, and the machine that actually picked up the blocks and put them in the bucket.
You can actually see the yellow robot arm in the background of that picture.
Okay.
That uses to move around the objects. And it's just like this handheld thing with just a ton of like square buttons on it. And it's like, how do I work this? And it took us a long time to figure out, like, because there are certain buttons that do certain things, and you have to set like, so you actually move the robot to where